Hello everyone, this is Mike Matson, and today I want to discuss modular synth, and for my demonstration I'll be using Zeta. As was discussed in the lectures, modular synthesizers are laid out pretty cleanly in that you can see the sections that you want to work with, and I'll walk through the 5 sections quickly in order. The oscillator section, the filter section, the amplifier section is in the lower right, and the 2 main modulation sources are the envelope generator section and our low frequency oscillator or LFO section. In the oscillator section, Zeta has 6 oscillators, and the synth that I have loaded is actually using all 6. That's one reason why the sound is so robust. The oscillator section itself allows you to include the 5 modes that were shown in class, which is the saw, the square, the triangle, the generated sine, and the generated noise. There's also several others that are included in here. The way that the oscillators work is you can transpose them by notes or octaves. The mode that they're in is whether they're free, which means that the synthesizer, when the note is struck, whether or not the oscillator starts from scratch or whether it just continues in its oscillation pattern. Because of this, the sound will actually not be the same if you hit a note twice in a row. These are all the same note. It's all an F. That's what free does. The group is specific to the oscillators. You can have 6 oscillators. Add simply means that they go to the bus. And there's actually 2 buses. By default, unless if you modify this, bus 1 goes to filter 1, bus 2 goes to filter 2. You can also set these up so that they're in dual mode instead of parallel, which means basically they're routed together, so they'll be one after the other on the same bus. Adding is the most common, which means that each oscillator simply is added to the bus. So it's sort of like layering a sample. You can also have them ring, where oscillator 1, if it rings oscillator 2, will now change the sound of oscillator 2. It's driving the sound. It's actually driving. This is the drive on oscillator 2. And you can simply have them ring. And you can continue to daisy chain them together in this way. I'll set these back to add, so go back to what I had. Fine tune, output level, and spread. This is the stereo spread. And this is oscillator by oscillator. So as you can see, just from getting started, the oscillator section alone adds for a lot of variability. In the filter section, we have 2 filters, and as we saw in class, we have a cutoff frequency filter and a resonance filter. The band level that can be run in parallel or dual mode. Parallel means that they're run 1 per bus, and dual mode means that they're daisy chained into each other, routed in order along the bus. The type, we have what we saw in class, which is the 24 decibel per octave low pass filter. We also have high pass filters, bandpass filters, and band reduction filters, which are notches. Forma, which is the human voice, essentially, and 3 resonant filters, and a comb filter. For this patch, both filters were set up to resonant filters, which is where you get the sound from for the synth. A lot of it's in here, and when you're actually modifying a voice, these are the 2 primary things that'll change the sound of a voice, is cutoff and resonance. And you can listen just adjusting one of these 2 filters what this does. And set it back. I actually have to switch settings to set it back. And this is how much resonance is on it. The two most common things that will affect sound are cutoff and resonance. So when tailoring a voice, the underlying patterns, yes, they will affect it quite a bit. However, the actual voice itself can be tweaked a lot here. The next section I want to jump into is the envelope generation section. There's actually 6 envelope generators, 1 dedicated to pitch and 1 dedicated to the amplifier, which is the master output. This is the one that was shown in class. Z3TA actually has a couple options that are not available on the one shown in class, which is a delay after you hit the key before it even sounds. You have an attack, which is shown in class. This is your attack time. You have a decay time, which was also shown in class, but Z3TA also includes a level. So you can actually put a notch in here if you'd like. The decay level, the sustain level, which is identical to what was in class, which is here. And you also have a sustain time, which is the time between the decay time and the sustain time. So there's another notch in here. There's a different point in here and in here. And then you also have the release. And you can adjust these by clicking here or double clicking on the nodes. That'll adjust all of your pitch envelopes and envelope generators, all of your envelopes in here. Next section, we have the LFO section. In Z3TA, there's actually 6 LFOs. 2 are per voice, which means per note. So if you play 2 notes at the same time, what it does is it affects each note separately in the voicing. You also have the ability here to add more than one waveform to the low frequency oscillator. And an interesting point, which is not shown in this, is if you use time morph, what this does is it actually morphs between the 2 settings, and it does that over time, and you can actually watch it morph, which is interesting. So you can go in there and you can take any of the waveforms, add to time morph them, and what it does is it morphs them at a periodicity which is the same as a low frequency oscillator, and it morphs them by a given amount. And you can actually hear a little bit in here. The master section is very simple. It's very straightforward. The master section consists of how many voices you allow. This is also the main output to the amplifier. So if you want to transpose notes, you would do it here. And when you're currently playing something, this will also show you how many voices are playing. That's 1 note, 2 notes, 3 notes. And lastly, I want to discuss the modulator section. The modulator section is identical to what was discussed in class. You need to have a source. Low frequency oscillator 1 is the source to this range. I can adjust the range, lower end with a right click, upper end with a left click, what type of curve you want to apply to it, and what it's actually going to. What is it going to control? And it's going to control filter 2's pan. So it's actually controlling the pan on this filter. This can get very complex. That's a quick overview of the modules that are common to most synthesizers and specifically to Z3TA+2. I hope that you found this information useful. Again, this is Mike Matson, and thanks a lot for watching.